Assalamu alaikum. My name is Naila and I am going to teach you people elementary or basic mathematics and states. This is our lecture number 1. So in lecture number 1 we are going to cover these are the contents like set theory, denoting a set as an object, ways of describing a set, types of set, basic operations of set, findings from set theory. Moving toward our first slide, that is set. In our previous classes, we have already learned about the set. So the definition of set says a set is any collection of objects specified in such a way that we can determine whether a given object is or is not in the collection. It means when the objects come in a particular form of collection, it makes a set. Or in other words, you can say that A is a collection of objects. So in a set, you people can see we have the objects. These objects are called elements or members of the set. In this example, you people can see that A is equal to A, B, D, 2, 4. So these are the objects like A, B, D, 2, 4. These are called objects and they come in the form of collection. So when they make a kind of a collection or particular set, that is denoted by A. In the same way, another example you can see B is a set which have the objects as math, religion, literature, computer, science. So in any other kind of set, you can see the particular objects, whenever they come in the form of collection, they make a set. So here you can see that is already written that the following points are noted while writing a set. Sets are usually denoted by a capital letters like A, B, S, C, etc. These elements of set are usually denoted by small letters, like the objects of the set are denoted by the small letters like A, B, T, U, and etc. Now we will come toward our next slide, which says that how should we donate a set? Like every kind of a set can be donated by a different type of alphabet. Here you can see that where it is desirable to refer to a set as an indivisible entity, one typically donates it by a single capital letter. Keep it in your mind that here we have to represent a set with a capital letter or a single capital letter. By convention, particular symbols are reserved for the most important sets of numbers. Like there are some particular types of set. Like here you can see empty set that is represented by this symbol. Another complex number of set that is represented by a capital C. And other type of set that is called as natural numbers of set that is represented by capital N. Another one is a rational number which is represented by Q, capital Q, and in the same way real numbers is represented by the R, and integers that is represented by Z. So these are the examples. These are the different types of set. Now what is empty set, complex number of set, natural numbers of set, rational numbers of set, real number, integers, prime numbers. So there are different types of set. So we will go through that what are these sets later on. But here you people only come to understand that these are the capitalized letters which have to be represented only the particular type of set. Like rational number has to represent it by only capital Q. In the same way, natural number of the set should be represented by only capital N. It cannot be represented by Z or C. It only be represented by N. So I think it is clear. We will move toward another slide. Now how many ways are there for describing a set? Particularly, we have three types of representing or describing a set. Like number one is list the elements. It means simply you can represent the elements or object of the set in the form of list. Like here you can see A is denoted as a name of set, that is equal to 1, 2, 3, 4, 5 and 6. Means there are, this is a set A which starts from 1 and end with 6. It is clearly understood. So this is a kind of representation of representing or describing a set, which is called listing the elements. Moving toward another type, that is give a verbal description. Means another way of describing a set is a kind of a verbal description. In this form, you people represent a set in the form of verbal clarification. Like A is the set of all integers from 1 to 6 inclusive. It means that A is a set which contain the object related to integers which starts from 1 and end with 6. So this was the second way of describing the set. Last but not the least is the third one, which is give a mathematical inclusion rule. This is also called as representing a set with a set builder notation. In this form, you represent the set with particular keywords. Like here you can see, if we want to represent this set in the form of mathematical inclusion rule, so you will write the set in this form, like A is equal to integers x such that 1 is less than equal to x is less than equal to 6. Means x comes in between of 1 and 6. It can also be read like this. So in this form of representation of a set is called the mathematical inclusion rule or set builder notation. So I hope these are the three main ways of describing offset is cleared. Now we will move toward the types of set. Like in previous slide, we have seen that there were many types of set, like empty set, natural number of set, whole number of set. So here we will see some special types of set. First one is the empty set. Now what is empty set? As the name suggests, empty means when there is nothing inside of the set. So what does it say? A set that contains no member is called the empty set or null set. Means empty set is also called a null set, and it is written as like this, curly brackets and nothing in between of these curly bracket, or it is denoted by this symbol, right? So an empty set is a set when there is nothing inside of a set, no element or no object in between of this curly bracket. So this is called the empty set. Next one is the finite sets. What is the finite set? A set is a finite if it consists of a definite number of different elements. If W can be set of people living in a town, then W is finite. Means when a set is there and it has a limited number of set that is defined. Okay, so here example is given that if W be the set of people living in a town, then W is finite. If I ask you people that how many students are there in your class, just name that students. So there will be finite number of student in a class. So that is called finite sets. In the same way, next come is infinite set. Now what is infinite sets? An infinite set is a set that is not a finite set. Infinite sets may be countable or uncountable. So it means that when there is no limit of of a set that is infinite. Mean opposite of finite set is called the infinite set. Here you can see the example that if we call that the set of all integers like 0, 1, 2, and in from this side is -1, -2, -3, and these dots are representing that the elements are unlimited, means infinite, there is no limit, they are going on. So it means this is a kind of a set which is infinite. We do not know that where it will end, so it is uncountable, right? So this kind of a set is called infinite set. In the end, you can see there is another set that is equal set. Now what is equal set? Equal sets are set which have the same members, means like if there are two sets, they have to have the same objects. Like P is a set which contain the objects 1, 2, 3. Q is a set which contain 2, 1, 3, and R is another set which contain 3, 2, 1. Means these three sets are equal. Why they are equal? Because in P, Q, R, their objects are same, like 1, 2, 3, or just order is changed, but the objects are the same, like 2, 1, 3, 3, 2, 1, right? So these sets are called equal set. These are represented by like this, like P is equal to Q, Q is equal to R, they all are equal, right? So now we will see what is another type of set, that is called subsets. Now what is subset? Sets which are the part of another set are called subset of the original set. Now what does it mean? When here in the example you people will come to understand that if A is a set, like A is equal to 1, 2, 3 and 4. B is another set, like B contain 1 and 2. Like in B you people can see only two objects are there. These two objects is also included in the set A. They are the part of set A. So B is a kind of subset of A, right? So it is called what? This is called a subset. Clear? Like 1 and 2, B is a smaller set, and the object what that are present in set B is also present in set A, right? So this is called the subset. B is a subset of set A. Now moving toward another type of set, that is power set. Now what is power set? If A is any set, then one set of all are subset of set A, that is called a power set, right? Means that in the example you people will come to understand that if S is the set, like S has the object like X, Y, Z, the power set of S is, if you want to make the power set like empty set, X and Y, right? In the same way we can also include Z, X and Y, X and Z. Like here in this we are making the pairs of the set S, right? So S is called the power set. Clear? Like if you want to break this set X, Y, Z into small possible sets, right? So in the first we have to write the empty set, then singleized, make the singleton set of these three objects, like X separately written, then Y is separately written, then Z is separately written, right? Then we are making the pair like X and Y, then X and Z. Then another possible pair of set is Y and Z, and in the end again the same set X, Y, Z. So how many pairs come in this set? 1, 2, 3, 4, 5, 6, 7, 8. So this makes the power of the set, right? Now moving toward the another type of set, that is called universal set. Now what is universal set? A universal set is a set which contains all objects including itself. Like you people can say that universal set is the biggest ever set which contain all the objects. Okay, like A is here, B is here, C, D. So these all are the set in which A is only the universal set. Okay, like if A contain 1, 2, 3, 4, 5, 6, 7, 8, and B is another set which contain 1, 3, 5, and 7, and C contain 2, 4, 6, 8. Now you people can see that B and C both the subset of A. D is also the subset of A. Okay, why? Because the object that contained by B also the part of A. These objects which is contained by C are also the part of set A. In the same way, the objects which are contained by set D are also the part of set A. So the biggest set over here is A. So will become the universal set, right? Here commas are missing. So in representing a set, we should divide or separate the objects with commas. So I will put the commas over here and I will send you this PowerPoint presentation to you people. So far we have studied the types of set, right? We have seen what is empty set, we have seen what is finite set, infinite set, then we studied the universal set, right? So now we are going to study that what are the basic operations which we are going to apply on the set. So these are the main three basic types of the operations of the set. Sorry. So first one is the union of the sets, another is the intersection of the sets, and in the last we will study complements of the set. Okay, so we are going to go through these sets one by one. Now what is union? As the name suggests, what is union? What do you think? What do you mean by union? Of course, union mean to join something, na? So here in the same in the case of set, we will join two sets. Okay, so what does the definition says? Like the union of two sets would be wrote as A union B, which is set of elements that are members of A or B or both two, right? Means if there are two sets like set A or B, okay, and they have the separate or maybe the same types of elements, so we are going to join them, we are going to combine them together. So in this example, you people can see that if A is a set which contain 1, 2, 3, 4, and 5, and B is another set which contain the elements 8, 9, and 10, then the A union B comes in this format. Like we are going to join them in a order, okay, like 1, 2, 3, 4, 5 till here. These are the objects of set A. We are going to add the elements of set B, like 8, 9, and 10. Okay, and the union is represented by this U, capitalized U, A union B, right? So this make a kind of union, first basic operation of the set. Okay, now come toward another type, that is intersection. Okay, now what is intersection? Intersection means when it is a kind of a set of elements that are both in A and B. Okay, means when they are common in A and B. okay, and it is represented by like this: A intersection B, right? So in the example we will see that how the intersection of the two particular set comes. Like if we have a set A that is equal to 1, 2, 3, 4 and 5. Another is B. B contain the elements 2, 5, 8, 9 and 10. Then we can make the intersection of these two sets. Now we will see what are those common elements in these both sets. Here you can see one is the part of A but not included in B. 2 is the part of A, it is also included in B. So this will come over here, right? 3 is only the part of A, it is not present in B. 4 is only the part of A, not present in B, right? 5 is also present in set A and also it is present in set B. So it is common in both set A and B. So we will mention it over here. Now you can see 8, 9 and 10. These three objects are only the member of set B but not present in set A, right? So these both are the only the common elements of set A and B, 2 and 5. So it is represented by A intersection B, and that is equal to 2 and 5, right? So this is the another basic operation of set. So here you people have seen that we have only written the common elements of two sets, set A and B, right? So we will move another slide towards the another slide. Complements of the set. Now what is the complements of the set? Like we have studied union of the set and intersection of the set. Another type is the complements of the set. So here we see that if A is any set which is the subset of a given universal set, then its complement is the set which contains all the elements that are in U but not in A, right? So we will see in the example what does it means. For example, U is a universal set, okay, and this is a kind of a finite set because it is limited. It starts from 1 and end with 10, right? So here you can see that these are the objects of U, universal set. Another set is A, that is given 2, 5, 8, 9, 10. Like how many members are there? 1, 2, 3, 4, 5 members of A, and 10 elements are present in set U. So we are going to subtract, means what is written in the definition, that A complement will be that we will mention that elements which is present in U but not present in A. It means it is a kind of a subtraction, okay? Like we will not write the common elements, we will minus the elements from U. Now it is present, 1 is present in U, it is not present in A, so it will come over here. 2 is present over here in U set, but it is also the part of A, so there is no any common means this is common element, so it will not come in complement set, right? In the same way, 3 is present only in U, it is not present in A, so 3 will come over here, okay? 4 is the part of U but it is not part of A, so it will come over here. 5 is the part of U, it is also the part of A, so it will not come over here, right? Because it is common. 6 is only the part of U, it is not present in A, so it will be represented or it will be written like this, right? Means it will come in the complement part. In the same way, 7 is the part of U, it is not present in A, so it will come over here, okay? 8, 9, 10, these are the three objects which are also the part of set A, like 8, 9, 10. So it means these are the common element. These will not come in the complement set, right? Those elements will come only which are the part of U but not the part of A. So it will come over here 1, 3, 4, 6 and 7, right? So these are the complement of set, and it is represented by A and C, like small c on the top of A. So it is represented like this. Okay, so I think it is clear. The basic three operations of the set we have studied. First one was that union of the set, another was the intersection of the set, and then we have seen the complement of the set, right? So in the end, we will see that we have studied so far the set theory, right? We have seen types of set, we have studied the operations of set, how to donate the set, but what are the findings? Where do we use the set theory? So in this slide, you people can see that set theory is used in almost every discipline, including engineering, business, medical, medical related, health sciences, along with natural science. Means this is very important. Set theory is very important. It is almost teach in every field of study. Like in business operations, it can be applied at every level where intersecting and non-intersecting sets are identified. We have studied the intersection of the set. So we have seen that we have choose only the common elements or common objects of the set. So we are going to apply over there. So in business operations, sometimes it comes that we need to find out only the common elements or objects during the statement study or transaction process. So we are going to apply the set theory over there, right? So example is also given there, that for example the sets for warehouse operations and sales operations are both intersected by the inventory set to improve the cost of goods sold. The solution might be found by examining where inventory intersects both sales and warehouse operations, right? So in this example, you people come to know that how warehouse operations and sales operation both are intersected, so that in the business we can improve our costs of the good. Okay, so in this way the set theory provide the best solution while making the cost of the good to improve the costs of the good, right? In the same way, we also apply this set theory for security purpose, right? Risk management and system analysis. And sometimes we as you people know that we are on hazard risk. Okay, and for managing that systems, for analyzing that security purpose related systems, we use set theory. There we also keep check and balance between different types of things, and there we can make different kind of complements of the set. Means we apply there on different scenarios, right? For experimental result between two or several types of objects, we can see over there that whether this theory work possibly wonderful or not, right? So these are the examples where we apply set theory. So far we have studied these topics which we have covered in this presentation, like set theory. In that we have seen that what is set, how to donate a set, what is the object, what is element, right? And we have studied that how many types of describing a set are there. Like we have studied three basic types of describing a set, right? In that we have studied just listing the elements, just or another type we have seen the verbal representing the set, and in the last we have seen what is a kind of tabular method of representing a set, right? In the same way, we have studied what are the basic types of set. We have seen the what is empty set, what is subset, what is power set, right? So these are the other main types of sets we have studied. And we have applied some basic operations of set. In that we have studied that what is union of the set, what is intersection of the set, and what is the complement of the set, right? And in the end we have studied that what is the finding of the set theory, that where do we apply the set theory and how it is applicable and suitable for different type of applications or field of studies, right? So now we I want you people to have some exercises which you people can solve. Here I want you people to do some homework or assignment, right? What you people have to do, first of all, you people have to find out that what other main types of sets are there. We have in this slide we have touched some types of set, but there are also some other types of set like natural set, right? Whole numbers of set, and integers, prime numbers, odd numbers, even numbers, rational numbers, real numbers, so you people have to find out that what are the definition of these sets and what with examples, okay? So you people will see this. You can say it as a types of sets. Another type, another assignment is over here, or classwork is homework is you people have to do some basic operations of set, okay? Find out union, intersection, and complement of the following. Like if u is equal to one, two, three, 5, 6, 7, 8, 9, 10, 12, 14, 16, 18, and 20, right? And A is equal to 3, 4, 6, 8, 10, 12, 14, 16, 18, and 20. And B is equal to 1, 3, 5, 6, 8, 9, 10, 11, 12, 15, 16, 17, 18, 19, right? So these are the, here you will have to find out A union B, A intersection B, right? And A complement and B complement, right? A union B, intersection B, A complement, and B complement. So this is going to be your assignment.